Okay, so today we have SBAC Practice questions 2. So this is our second practice. We're going to answer the following questions. So the first one says, Ashley has a savings account with D dollars in it. She plans to withdraw W dollars each month for M months. So I'm going to circle my variables that they want me to use. Write an equation for the total left T, so her total left, in the account after T months. So her total is going to equal, well, let's think about this. How much does she have at the beginning? Ashley has a savings with D dollars. And withdraw, so you do need to know that withdraw is, what she's taking out. So she's taking out W dollars. And how often is she doing this? She's doing this each month. So we would multiply those two values. So if she's taking out, let's say she's taking out $10 each month. So on the first month she took out $10. Then W, she's taking out $10. And the second month she took out another $10. And the third month another $10. And the fourth month another $10, and so forth. So over, let's say, 10 months, you would multiply these together, subtract from what she started with, and that would be her total. So this is the equation that represents it. For question number 2, it says select yes or no to indicate whether each value of x is a solution of the given equation. So we can take this value and we can plug it in and see if it works, or we could multiply. So our denominator here is 1. We could cross multiply here and we could solve. I personally think that it's easier for me just to plug these values in. So that's what I'm going to do. I plug in a -2, and I have a -4 on top, and the -2 and the -2 here make a -4. That's one side of this. On the other side, I have a -2 plus 3. So -4 divided by -4 is 1. -2 plus 3 is 1. Is that a true solution? Yes. It worked out. Then if I plug in 1, I would get, let's see, on top I have -4, on bottom I have 1 minus 2, and over here I have 1 plus 3. So 1 minus 2 is -1. So I'm going to write a -1 here. And a -4 over -1 is a +4. 1 plus 3 is 4. Again, that worked out, so this is a solution. Now for -3, let's see. I have -4 on top. I have a -3 and a -2, which is -5. Over here I have -3 plus 3. So -4 over -5 is 4 over 5, and -3 plus 3 is 0. So that does not work out. So this is not a solution. Alright, moving on to question 3 and 4. So question 3, it says John is studying the function f of x shown in the graph. He claims that he can transform the function to include the ordered pair 2, 2. So he's saying he can move this or transform this to include this point. So if we were going to include this point, we would have to shift this graph over 1, 2, right? And then it would look something like this. So how do we shift this blue function over to this red function? Well, we have to shift it in the x direction, right? We have to shift it over 2. So if I look at these, I have to think about this. Am I wanting the change to happen to the x, which is what we have here, or do we want it happening to the y? Remember, f of x is just another fancy way of saying y. So do we want to shift the y, or do we want to shift the x? Well, we already said we want the x. So it's not going to shift the y, which is these two. That would take our function. Remember, let's say we have x squared, and if I put a +2, that moves our graph up 2. So it would go from here, 1, 2, and it would go up 2. And I don't want to go up or down, which is what these are doing. I want to focus on my x's. Now remember when we talked about vertex form, we had x minus 2 squared. That inside is our x value of our vertex. And remember, we always switch that sign because our formula is x minus h squared So if we're going to flip the sign and we want to move in the positive direction, then it's actually going to be A. Right? This looks like we're saying, oh, move the x plus 2. But remember, our formula for a quadratic is actually to switch that sign because we have x minus h squared plus k. Alright, for question number 4, it says select the ordered pair that is a solution to the equation represented by the graph. So if it's a solution, it would lie on this graph somewhere. Okay. Now if it said select the ordered pairs that were the zeros, right, then these are the points that we would be talking about. But does it say to find the zeros or the roots? No, it just says find the point that is a solution. So like this point here is a solution, 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 this one, and so forth, right? All those points on this quadratic are a solution. So let's see. Is negative 3 a solution? Negative 3, negative 3. No, that's not a solution. Okay, let's try this one here, B, negative 1 and 0.75. Okay, that one looks like it could be it. Let's try C. C is negative 4.5, 2. That point up there is not on this. And D, negative 2, 1.75 is not. So it looks like B was the only one that was a solution, the only one that lied on this function. For number 5, it says which equation has no real solutions? So this is back to first semester, and if you remember when we did the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember, if you get a negative number in a radical, we would get an I, right? You can't have a negative in a radical, so we take that I out. So right here is what determines if we're going to have real solutions or not. So it says which equation has no real solution. So we do want this to be an imaginary. So we want this to be a negative number or less than 0. So that's what we're going to be using to determine this. So this is called the discriminant. Not sure if you guys remember that. So what we're going to do is we're going to identify A, B, and C in each of these and see which one satisfies this. Which one has b squared minus 4ac is less than 0. So for A, we have negative 1 as our A, negative 3 as our B, and 5 as our C. So let's try to plug these in. So A would be negative 3 squared minus 4, let's see, A was negative 1 and C was 5. So here I have 9. A negative times a negative is positive, so that's 4 times 5 is 20. And I need that to be negative. Well, that's not going to be negative, so I'm not even going to continue any further there. Let's try B. B, I have 1, 3, and positive 2. So let's see, b squared is 3 squared minus 4a, and then c was 2. So 3 squared is 9. Negative 4 times 1 times 2 is negative 8. Again, that's positive 1. That's not going to give me a negative. So let's try C. A is 2, B is 4, C is 3. So 4 squared minus 4a is 2, and c was 3. What's that? 8 minus, no, well, sorry about that. 4 squared, not 4 times 2. 4 squared is 16, and then negative 4 times 2 is negative 8, times 3 is 24, and that will give me a negative number, right? I get negative 8, which is what I'm looking for. I'm looking for my discriminant to be less than 0. So C does satisfy this. Let's see if D does, because remember on the SBAC you can have multiple answers on some of the questions. So for D I have 2, -5, -3. -5 squared minus 4 times 2 times -3. What do we have? 25, so 5 squared is 25, minus 4, so this negative times this negative is going to give me a positive. And let's see, that's 8 times 3, which is 24. Again, a positive number. So our only solution here is C. Okay, for question number 6, it says find the value of x that makes the equation true. So I'm going to go ahead and solve this by cross multiplying. I'm going to get 6x equals 7 times x plus 1. And now I'm going to distribute that. So I have 6x equals 7x plus 7. And now if I subtract over the 7x to move all my x's to one side, I get negative x equals 7. So when I divide by that -1, I'm going to get x equals -7. And now I always like to check my answer, so plug that back in and see that you get a true statement. So 7 over -7 equals 6 over -7 plus 1. So this side gives me a -1, and this side here, let's see, 6 over, -7 plus 1 is -6. So 6 over -6 is -1. It's true. So this is my solution. For question number 7, it says select which options has or have one real solution. So there could be multiple answers here that have one real solution. So let's go ahead and solve these. So if I add 11 to the other side, so for A, I add 11 to the other side, and I get x squared equals 16. And if I take that square root, remember you're going to get x equals plus or minus 4. That's two solutions. So that one does not have one real solution. So part B, let's try that one. B is the square root of x minus 12 equals 3. I add 12 to the other side. The square root of x equals 3 plus 12 is 15. And to get rid of this square root, I square both sides. Now when I square something, I do only get the one solution. So I get 15 squared is 225. So that is one solution. Let's try C. I'm going to erase A to give myself some more room here. And let's put C right here. So 2 times the square root of x plus 8 equals 2. I subtract 8. 2 times the square root of x equals -6. I divide by 2. I get square root of x equals -3. And when I square both sides, I get x equals 9. So again, that one does have one real solution. All right, let's try D. So D, I will cross multiply, and I'll get 2x plus 2 equals 3x minus 1. Distribute. 2x plus 4 equals 3x minus 3. I'm going to move my x's to this side, so subtract 2x and add 3. So over here I have 7 equals x. 3 minus 2. So again I get one solution. So B, C, and D all have one solution. I'll continue the rest of the questions in another video.